Hey guys, I hope it's going well and you're adapting to this online world. If you have any questions, obviously, please don't hesitate to message me, email me, whatever you want to do. We can chat on video conference as well. But this is our second lesson. So we're switching over from what we did last unit, which was one variable statistics. So mean, median, mode, all that stuff with standard deviation. And we're looking at when you have two variables. And so there's a bunch of stuff you can do when you have two variables, and it's more often that you have two variables. You can always take each of the two variables and analyze it for each of them in one variable ways, like the mean, median, mode and stuff. But so we're looking at multivariable statistics where we're comparing two or more variables. So you can just fill this note in, and we're comparing them to each other. So as one variable changes, so does the other. And so the first example I think that's good is actually what you guys did, which was, remember we did a lesson or an activity where we measured a whole bunch of things, including height and arm length. So this is your data, or our class's data, of height and foot length. So this stuff over here is you. So not everyone did this, but this is the data that was available. So one of these probably represents you. So the first person is a height of 190 centimeters and 28.5 foot length. So I've actually already plotted it, but we're going to go ahead and just plot this. And this is what a scatter plot is. You have one axis with your x-axis, which is your independent variable. So I'm going to call that my height. And your other axis is going to be whatever the other thing is, and this is foot length. And obviously you include your units in each one. So when you do this, and if you are doing it by hand, the best thing to do is to identify where your highest and lowest points are. So if I look at my height, I can figure out a range. So my highest is 190.5 minus 158.5. So that gives me a value, or a range of 2, or 32 rather. So that when I go to look at my scale here, so when I look at the y-axis, so from here to here, there's about 14 bars that go up. So that's going to help me determine. So if I wanted to find how much to put for each tick going along, like these are my ticks going along, I would simply take my range and I would divide it by the number of bars or ticks there are. So if I do that, that's going to be approximately 2 point something. And generally, if you round it up, that's going to make it a bit easier so you can fit all your data in. So when I do this, notice our lowest point is 158. So there's really no point in starting at 0. So what I do is I put in a break like this. So again, we've seen this before, but that's a break in my graph, so it doesn't start at 0. And I'm going to start, so if it starts at 158.5, I'm going to start this one at 158. I'm going to make each tick worth 3, so that every 2 ticks I'm going up by 6. So this would be 164, and 170, 176, and so on. And again, this just ensures that we get all of our data in the graph. So we're going to do something similar on the x-axis. So again, let's just highlight what the highest and lowest are. So if you scan, I got a 30.5, that looks like the highest, and my lowest is 21.5. Who's that? So if you figure out again your range, we get a range roughly of 9 centimeters. So my width, if it's 14 again across, ticks across, we can really do it so we have one, each tick is 1. So we'll start here again at, let's say 20, because we've got some extras. This will be 21, 22, and so on. And so, again, I've already plotted this in, but you can take a moment to plot that. And so I'll just delete this line of best fit. So we end up with this relationship here, and you can notice there's kind of a trend. And this is what we're looking for in two variable statistics. We're looking for trends in data. So in this case, it's obvious that your height is somewhat related to foot length. And it's not always the case, but there is a pretty strong relationship here. So if I drew a line of best fit roughly, so at this point we're just estimating this line of best fit, but we will be able to calculate one soon in another lesson. So clearly this looks like a positive relationship, whereas one value increases, so does the other. So the x goes up, the y goes up. And so it's a positive, and it would look like a fairly strong relationship. And that's the kind of thing we're going to be talking about right now. So in general, you could estimate someone's height based on their foot length or vice versa. So this is what we call a correlation. So two sets of data are correlated if changes in one cause predictable changes in the other. And we're going to be going through a lot of why that is, or if it's causation versus correlation, but we'll talk about that a bit after. So in this case, one variable is the independent, so that's the one that goes on the x-axis, and the dependent one obviously is going to go on the y-axis. So scatter plots are useful to visually reveal the relationship between two variables. Again, it doesn't necessarily mean that one causes the other, but it definitely represents a correlation between the two. So one way to measure the strength of how correlated two things are is to use what's called the correlation coefficient. And so this should be new for most people. And it's this variable represented by R. And it's a measure that goes from -1 to +1, where -1 would be a negative relationship and +1 would be a positive relationship. And so it's useful to use this value in order to figure out how correlated two things are. And so there is some crazy formula to calculate this coefficient, and it involves a whole bunch of data calculation that we're actually not going to be using, but we are going to use software and our graphing calculators. So we're going to use graphing calculators and graphing software to solve for R, but you could do it by hand. So as I was saying, we have positive values. It means a positive correlation. So that's where you've got something like this. So this is positive, obviously, and this is grade 9 stuff. This would be a negative correlation. So if two variables are completely correlated, it would mean that you have every point is on this line of best fit, which is not that often to happen like that. So we more often get into ranges between -1 and +1, where we have strong, moderate, weak negative relationships, and then we go over, if it's 0, it means there is no relationship between them. And then we get into positive ones where we have a positive weak, positive moderate, and strong. And so any number between these gives me a negative, and then same with the positive. So for example, here, if we've got something like this, imagine a line of best fit going down, something like that. And so that's a pretty strong negative correlation. This one will be moderate, where the variables are clustered around the line of best fit. And then the last one here would be where you really have no relationship. And then similarly here when we have positive ones. And again, a perfect relationship would mean everyone is on the line of best fit. So we are going to use our calculators in order to solve and figure this stuff out. So what I'm going to do is I'm going to switch to my laptop, which I have a virtual TI calculator, and I'll show you how. Okay, let's take a look at the question here. It says we're going to graph the following. We're going to try to create a scatter plot on our calculators, classify the correlation, and then find the correlation coefficient. If you happen to not have a TI calculator, what I was able to do is I was able to download this virtual one. If you just Google TI emulator or calculator online, You should be able to download and get a 90-day trial version, so you can do everything if you want on your computer. So I took this data, which is real data, and it looks at the fat content of various hamburgers at different places, so like McDonald's and stuff, and then takes their calories. And so we're trying to look to see if there's a correlation between the amount of fat and the amount of calories in a burger at various places. So what we're going to do is take all this data here in the two columns, and we're going to put them into our plot here. So first thing we need to do is to go to Stat here and then press Edit, and that will open up our various values here. And so if you look at this, we've got, you can input, I've already inputted all this information. So this column I put in for L1, and then the next column's for L2. That's great. So then in order to get out of there, you can press second function mode, and that will quit. Next thing we have to do is we have to turn on what's called the diagnostic tool. So this will be new for most people. There's two ways to do it. The easiest way is to go to mode. So click on mode. And as long as you have a TI-84, you can scroll down here to stat diagnostic. And so it's defaulted to off. So you should see yours like this. So it's off. What you want to do is scroll over to on and press enter. And that's going to allow us to get the correlation coefficient. So in order to get out of there, I just take second function mode and get out. If you have an older TI calculator, what you have to do is press second function 0, and you scroll down until you get to diagnostic, and you then turn it on. And it takes a long time for me to do that here, so I'm not going to go through all the steps, but just scroll down until you get to diagnostic and turn it on. So once you get that, you're good. Next step is we need to perform what's called a linear regression in order to classify the correlation. So in order to do that, let's here go to calculate, and we scroll down to linear regression. So you press enter, and this is my X values and these are my Y values. So at the moment I've got the wrong list in, so I need to change this. So I do lists are down here, L1, L2, L3. So I'm going to do second function 1 gives me L1, and then list second function 2 gives me L2. And then you can just press calculate, and it will do the calculations for you. So what it does is it creates the line of best fit for this data, where A is the slope, so AX plus B instead of MX plus B. A is the slope, B is the y-intercept. The R squared is the correlation coefficient squared. What we want is this. So this gives us an R value of 0.97, which I've written here. So I get a correlation coefficient 0.97. So if you look at this, we're somewhere between here and a perfect correlation between the two variables. So it's a very strong correlation. And so to classify it, I put this as, that should be C and this is B. It's a strong positive correlation. So if you wanted to graph this to see it on here, what we would need to do is you go to second function y equals, and we would turn on plot. It doesn't matter which one you turn on. So I've already got plot 2, so I'm going to take it. So you have to scroll to turn it on, and then you go to what you want your list to. Again, I've got the wrong list in, so I'm going to change it to L1. Oops. And then I'm going to change this one to L2, so that's my Y values. And the other part we have to do is, because these values are not standard, we need to change our Windows settings so we can see them. So my X values here, if I just shrink this, my X values go from roughly 5 to 34, I guess. So why don't we make it from 0 to 40? And this is just the distance between the tick marks on the axis. So why don't we have it every 5? And then the Y values, if we want, we can start at 0. We don't have to, but I'm going to leave it at 0. And we're going up to a total max of 590. So why don't we make it 700? And we'll go up every 50 is our ticks. So now we're set up so we can graph this. So if you have everything inputted, you'll see this here. And so if you wanted to, you could actually type in the linear regression as well. You could go in and say y equals whatever the value was that we had there for the slope in the y-intercept, and it would graph it with this. And so this is what you see here for the scatter plot. So two things, we've got the correlation coefficient, and then we also have this, that knowing it's a strong positive correlation. So what I'd like you to do is take a few minutes and use this one. So this one's looking at the amount of horsepower, which is a measure of how much power a car or vehicle has, versus its fuel consumption. And so what I'd like you to do is similar to what we did. So you're going to use your graphing calculator, create a scatter plot, do the linear regression, and answer these questions here. And then you're going to actually go further and use the equation of line of best fit in order to estimate a couple things. So see if you can get that, and all of the answers are below. So if you look online, you'll find them here, and I'll just put this up. And if you wanted to, you could just pause right now and see it. Okay, so if you have any questions, of course, please don't hesitate to ask. So we'll continue on with two variable statistics next class.